So mixed review as far as it's going to have word problems. Most of the ones that I can remember back in the day on the EOC, it wasn't just like, here's a shape and it's labeled and they tell you to solve for volume. It is a matter of reading through and identifying what they are. Again, if you have any call outs, I'll take them as far as what you think might be a little more difficult than others. And I'll gear, future ed puzzles and future practice to that. If a bottle's in the shape of a square pyramid, so that means it's going to have a square base, and pyramid means it's going to come to a point at the top. So for me, I like to be able to, I'll sketch them out. Nobody judges your artwork. So especially after this, we start doing quadrilaterals. Sketching them out is huge, even if they're not perfect. Again, no one judging your artwork. This is a math class. But it helps sometimes to get your brain going in the right direction, because otherwise you may or may not attach numbers to the wrong places or letters, especially in the quadrilaterals. So then this bottle has a height of 7 centimeters. So height is always straight up and down. You will, and there's some examples further along in the packet where they'll give you the slant height. And the slant height is as if you were if you're thinking of a house roof being this pyramid instead of a bottle, it would be like where the shingles are, like along the outside. And when you're standing in an attic, and they say, how high is the attic? You don't stand at a diagonal. You stand straight up and down, like this is the highest point in the attic. So to remember, height has to be vertical, like straight up and down, not along the outsides at an angle. So it also says each side is 10 centimeters long. So 10 by 10. What is the volume of the bottle? Okay, so formula for all pyramids and prisms. So the way that I memorize them, because as we discussed earlier, the memorization of formulas is a little harder for some people than others. You always need the area of your base shape. So this is a square, which is awesome because most of us can remember how to find the area of a square, which is the same as a rectangle. So square, if you looked it up, if you Googled it, it would say side squared. But if you remember length times width, that's also a rectangle. So any dimension of a square or rectangle shape, length times width is going to be the bottom, and that would be seen as big base in our volume formula. And then it's times the height, so how high up. And then for a pyramid or a cone and a pyramid are the same as the prisms, except that they just pinch the top. And then a cylinder is a circular prism. So they all sort of relate. If you can remember, it's the area of the base shape and then the height. And then if they pinch at the top, I always think about pinching makes it look kind of like a triangle, like a cone. If I always remember the drinking cups, like if you're playing sports and they give you the big little white cups, and you find them on the ground a lot where people step on them and then they look like a triangle. So it's a 3-sided figure. So I think about that point being 3 sides. So it's 1/3 times your big B times H, or 1/3 in this case times length times width times height. Depending on what calculator you use and how good you are at putting things in the calculator, I am super worried my calculator is never going to understand what I'm trying to tell it to do. So I do all the multiplication and then divide by 3, which is the same thing as multiplying by 1/3. So in this case, that's 10 by 10 is our length times width. 10 by 10. Then our height is by 7. There's a point at the top. So we're going to divide by 3. So 10 times 10 is 100. Times 7 is going to be 700. And then we're going to divide that by 3. Just going to be a lovely, ugly number of 233.33 repeating. So then the volume would be this many centimeters cubed because it's a 3-dimensional figure. I haven't seen a lot of that in our class, but I have talked to a lot of other math teachers from different schools and different grade levels. And the centimeters cube and the unit of measure is a big deal for lots of other teachers. And not only are we trying to prepare ourselves for our class, the EOC, but you're going to run into other people along the way. So making sure to pay attention to whatever the unit of measure is in the word problem, and then remembering that volume is cubed. It's a 3-dimensional. Area is squared, and then just regular measurement is the unit as is, so a flat measurement. Number 2, so if a soda can has a diameter of 6 centimeters, so that means I have a can with a diameter, which is all the way across, of 6 centimeters. Again, this is a circular prism, so the base shape is a circle, no matter if our can stand straight up or falling over. And a height of 12 centimeters, So again, straight up and down, this is going to be 12. What is the volume of the canned soda? So again, thinking that the base is a circle, so it's big BH is what you're going to see a lot. Not hugely helpful if that's the one you memorize, if you don't think through it. There is no pinch to the top. That's why there's not a 1/3 in the front. But your big B is the area of the base. So this is a circle. An area of a circle is pi r squared. Then we're going to multiply it by the height. Also, my favorite story, and I don't know why, I think it's because I think it's so gross, is cylinders. If you think of like the Oscar Mayer bologna pack, it's a yellow pack of bologna, and you peel off the top, and then you can peel out each piece of bologna. And I don't know why. Like, I think bologna is disgusting, especially the way it sticks together. Just my personal preference. But the idea is that you would have the area of one piece of bologna, and then how many pieces of bologna are in the stack here, and that's where the height comes from. So for me, whatever reason, that visualization really helps. So I need how much area is in one bologna, and then how many are in the height. Again, helping me memorize the formula. Diameter, we are using radius, so you want to make sure we use that. So pi, and in this case, it's 3, half of the diameter is the radius, times 12. This word problem does not differentiate, but another big thing to be looking for when you're reading the equations or reading the problems is whether they tell you to use the pi button or whether they tell you to use 3.14. Usually it's in parentheses and they'll say like use 3.14. If it doesn't, the assumption is that you would use the pi symbol, because the pi symbol is the indefinite long number, which in every class, maybe prior to now, not a big deal. No worry about accuracy, but as I've spoken before, now that we're in Math 3, and we're going forward in our math careers, the accuracy does definitely matter. A lot of students get blown away when they leave answers in terms of pi. So 3 times 3 is 9. So we did pi times 9 times 12. So 9 times 12 is going to give us 108. So 108 pi is the volume. Now, if you see a multiple choice question and all your answers are in terms of pi, remember, this is just 108 times your pi button. You can switch them all to decimals. Like if you did all the math and then go back and realize, oh, I already pushed that button, I need to back up, then just turn them into the form you want them in. And so if we use the pi button for the most accurate answer, it's going to be 339.29. And then there's a 2006, that 2. So then centimeters cubed. So again, this is in terms of pi. And when we say in terms of pi, we're just meaning don't push the pi button. That's all that means. So if you see lots of answers with pi attached, all they did was whatever formula they were using, they did not use the pi button. And that'll really pertain more when you'll see it more in we get into circles and such things later on down the line. But the sooner you can pick up on in terms of pi what that means, the better. All right, the top of a castle's tower is in the shape of a cone. So a cone is a circle with a pinch top. So it's a circular prism with a pinch top. So again, volume equals big BH times 1/3 or divided by 3. And again, the part you have to remember is big B is a circle in this case. So that's pi r squared times height divided by 3. Now more details. The diameter of the cone-shaped roof is 10. So again, diameter is the whole thing, which is not what we use. We're going to use half of it because we just want the radius. That's going to be 5. And then the height, which is straight up and down, is 12. What would be the volume of the attic space? So how much space is on the inside of that attic space? We're going to use pi r squared, so pi times our radius, which is 5, squared, times the height of the cone, all divided by 3. Now, again, if it's a stack of bologna and no point at the top, then you would do the exact same thing, but not divide by 3. So that's going to give me 25 times 12. So that's 300, and I'm probably writing out more than you need to see. And more than I would expect you to do, but just so you see where all the things come from. And that would be, in terms of pi, 100 pi. Super accurate answer in that case. So 100 pi feet cubed would be a very accurate answer because that doesn't leave any room for you to miss round or all the extra decimals to like go away. If we're making a bunch of these and we wanted to multiply it, this would be your most accurate answer, because also there's no conversation in the equation whether you or in the question whether you should use the pi button or 3.14. But if we do use the pi button, it's 942.47777961. So we'll round to 8, and that would be feet cubed. So again, in terms of pi being your most accurate answer, because there's no rounding, and we can multiply that by 2 or 12 or 457.4, and you're still going to get the most accurate answer that way. And back to the slant height that I'd spoke about. So if we remember right triangles, so this makes a right triangle with a height of 12, a base of 5, and your hypotenuse, that would be your slant height. If they give you, remember this is a squared plus b squared equals c squared. If you're missing one of those important parts, like maybe they gave you the slant height and they gave you the vertical height and you need the radius, you can do a squared plus b squared equals c squared to find that missing part. And just a big call out not to go down a rabbit hole, your hypotenuse is always your c, as a reminder. Throw back to way back in the day, probably math 1 and math 2, but definitely math 2. All right, a cube and a cylinder, a cube with a cylinder cut from a center is cut along the plane shown below. Which of the following is the cross section of this solid? So because it goes this way, the idea that you're thinking is when I fold this guy out and I look at its face at that point that we'd be looking at, would I have a flat square? Would I have a square with a circle? Or a half circle, sorry, a hemisphere. I'm sorry, half circle. Hemisphere would be half of a sphere. Then just from this to me is quite obviously the top of the entire thing. And then this is when you open it all the way up. That's your cylinder in half. This shape would be just this half from a up top view, so from an aerial view. The full square would be one of the outer faces. And then again, like I said, if you open this, hopefully you see this one would be the inside here where they would see. Again, the GeoGebra activity is very helpful to watch it slide around. It doesn't have composite shapes necessarily like this where you would have a rectangle with a cylinder cut out on the inside. But hopefully if you mess with that one enough, you'll be able to kind of assume to what it looks like when it starts cutting apart. Now, number 5, these are the shapes that are on GeoGebra, and you can start moving these planes around to see that they make ellipses, they make circles, they make ovals, they make squares, they make triangles, and all sorts of things of that nature, because they are not always going to be a straight vertical or straight horizontal slice. In this case, this is horizontal to the base, would be if it was a word problem, how they might describe this. Horizontal to the base. And it's helpful to know what the base shape is, because as long as it's perfectly horizontal, it's going to continue to give you the same shape. In this case, because it pinches at the top, it will get a little smaller. So this one we can assume is going to be a slightly smaller circle than our base, because our base is a circle and this is a cone. Vocabulary, this is a hemisphere. So half of a sphere. If you have to find the volume of a hemisphere, you're going to find the volume of the whole sphere, get your answer, and then just cut it in half. Because it is half of an entire sphere. So think of like the globe. So this is the upper hemisphere of your globe, maybe, the way it's turned. With this slice, that's going to make just a flat hemisphere shape. So it may be, I'm trying to think of the words they would use to call that. A half circle probably would be what they would call that shape as it's sliced through. So again, it's when this opens this way, what would be on the inside in this face in here? What shape? Our cylinder, both of these would be vertical to the base. So straight up and down. If I cut this in half right down the middle and then I open him up, so again, maybe like a stack of bologna or a round wheel of cheese. I'm trying to think of things that are that shape that you could cut in half vertically. As it opens up, again, it's going to make a shape. And in this case, it should be a rectangle. A pyramid is much like a cone. Again, it's just like the prism, but what shape is the base? You could assume this is pretty close to a rectangle or a square shaped base. This again is horizontal to the base or parallel to the base. Like it's not going to cross into the base. It's just a straight left and right cut through. So you're going to have another rectangle or square, just slightly smaller through the top. If it was to slide down a bit and not be perfectly horizontal or parallel to the base, you would get more trapezoidal shape because it's going to get that the bottom of your pyramid is a little larger than the top. So if this corner was to come straight down this way, you would end up with a skinny top and then a wider bottom. So you would get a trapezoidal cross section in that one. So it would look like a trapezoid. And trapezoid, again, if you don't remember, in this case, it would probably be a lot taller, longer this way. But again, the GeoGebra is hugely helpful if you didn't flash through it, or if you go back and maybe, like I said, even star it for later, like closer to the EOC, because I can almost guarantee you there is going to be one of those questions. All right, Alexa says a basketball autograph by LeBron James. She wants to mail to her nephew as a birthday gift. The basketball has a diameter of 10 inches. So me personally, I would stop. Basketball, 10 inches diameter. We know we don't need diameter. She wants it to fit snugly in a box. She is mailing as to not waste any space. So what is the volume of the sphere? Sphere equation, most students mess up the most because it is a little bit more odd than the normal. Most all of our special shapes are our pinch shapes. We divide it by 3 or multiply by 1/3. This time it's 4/3. It is pi r cubed, not squared. So pi r cubed. So the biggest call-outs I've watched students make, we mess up here with the cube. They'll square it because we're used to squaring. And then the 4, they magically make it. They basically reuse the formula for cone. So make sure it's 4/3 and then r cubed, not squared. And again, we are still using the radius. So we're going to use half of that 10. So 4 pi times 5 cubed divided by 3. 5 cubed is 125. Multiply it by 4. Again, maybe oversharing. 500 pi over 3. We divide 500 by 3. That's a nasty number. So at that point, I probably would say that they are not going to leave this answer in terms of pi because that's 166.6 repeating. So I'm going to go ahead and multiply that times our pi button, and we end up with 523, 5, 9, 8, 7, and I'll probably stop there. We'll turn that into an 8 because after that 7 is another 7. And the only reason I'm leaving a couple extras is because now we are also going to have to be working on our box and we have to be able to compare. Now, if the diameter of the basketball is 10 and we're going to put it in the snuggest box we possibly can, a box is going to be a cube and it's going to have at least the width of 10 and the diameter runs all the way. So when I put my box back, that is also going to be 10. And then the diameter runs up and down as well, so that's also going to be 10. So we now have a cubic box, so a 10 by 10 by 10 box if we are going to close in as tight as we can around this basketball. And so volume of a prism, or in this case a cube is the side cubed, or length times width times height. If we have limited space in our brain and we're only going to memorize one of these formulas or the other, your second one, the length times width times height, is going to be the most applicable to all rectangular or square prisms. So 10 times 10 times 10, it's going to give us 1,000. And we're measuring in inches cubed. So this is also inches cubed. What is the volume of the unfilled space when the basketball is in the box? And that's talking about these little wild corners. So you're just going to take the difference from your basketball from the box. So we're going to take 1,000 and we're going to subtract our 523.59, and we can go ahead and turn it to a 9. Again, there will be some wiggle room because your answer may not, if they don't give you enough information in the question to round. Don't panic. The more accurate you are, typically the easier it is to move those numbers around a little bit and back up or round up to 0.6 instead of 0.5988 or just be aware you may not look down and find your specific answer if there's not details as to how you should round in the question. If it says round to the nearest tenth spot, that's one place after the decimal. 100ths is 2 places after the decimal. 1,000th is 3 places after the decimal. They will ask for that at times because, again, we are in math 3 now. I typically only go hundredths because money is the most common decimals that we deal with, and it does go to pennies, so that would be your hundredths spot. But again, there's a lot of wiggle room as far as that's concerned to whomever makes the question. If I do 5.99, our answer is going to be 479.4, and then has a 0, 1, so we can just leave it 0, and that would be our answer. And it would still be inches cubed because we're talking about all that area that the air is filling up in the box that the basketball does not take up. All right, Steve wants to fill a circular wading pool. The inside diameter of the pool is 100 centimeters. So we have a pool. The diameter is 100 centimeters, and the depth is 20 centimeters. What is the volume of the pool? So depth is height, so up and down. Again, this is our stack of baloney. Pi r squared is the area of the bottom circle, and then how many are in this case, the pool or our stack of baloney. It does not say whether to use pi or 3.14, so let's see what it looks like in terms of pi. If the diameter is 100 centimeters, we do want to turn that into 50 for our radius. So we're going to do pi times 50 squared times our height, which is 20. So this should be a fairly large number because we have 50 squared. And then we're going to multiply it by 20. So we should get 50,000 pi centimeters cubed. And again, if we were to use our pi button, so times pi, it's 115,707.9.63. That's with the pi button, centimeters cubed. If you used the 3.14, it is simply 15,700. So again, all 3 of these answers are correct. It's just which one the question is asking for, or the person who wrote the question. And if you think about it, I know a lot of people are like, oh, they're basically the same, except if this was money, it's $79.63 more in your answer when you use the actual pi button versus 3.14. And I don't know about you, but near $80 is a pretty big difference if we're talking about paychecks and things of that nature. So if they request that you use the button versus the 3.14 and it was an open-ended question, if you put in this one, it is wrong. So make sure to double back and read your instructions. So this is in terms of pi, again, as a reminder for vocabulary. In terms of pi, this is with the pi button, and this is with 3.14. So all are correct answers depending on what the question asks for specifically. Now, if you wanted to leave a 5 centimeter lip so the pool doesn't overflow when you jump in, what volume of water would you need to fill the pool? So if the whole pool is 20 centimeters high and we want to leave 5 centimeters, we're going to do the exact same thing, but instead of doing 20, we're going to leave that 5 lips. So that means that's a 15 height. That's all the water we're going to put in it. So the pool itself will hold that 157,000-ish centimeters cubed. But again, if you jump into a full pool, water's going to flow out. So typically people don't fill it all the way to the rim. Instead, like in this case, it'd be 37,500 pi centimeters if we wanted to leave it in terms of pi, centimeters cubed, or with the pi button, that turns into 117,809.72 centimeters cubed. And then again, just for the sake of hopefully hitting home, if I multiply it by 3.14, that's 117,750, which in this case is about 59 difference in change centimeters cubed. Though we are in a more accurate world of math because we're in Math 3, I will say most of the time, and this is not a hard line, this is just in general, they like prettier answers anyway. So if I was making a guess, it would probably be in terms of pi or with 3.14. But again, that's just a Sigmund guess, not anything that's based off of actual, like a rule across the board. All of it is fair game. So Sam is going to help Steve fill his pool to the very top by using a rectangular pail. The dimensions of the pail are 15 by 12 by 10. Assuming Sam can fill the pail to the brim all the way up, how many pails will it take to fill the pool? So if we're filling the pool all the way up, we need the 157,000 and some change. If we're filling it up to the 5 centimeter lip, then we need to have the 117,750 and some change if we want to go with the more accurate one. But our bucket is 15 by 12 by 10. So that means 15 by 12 by 10. And so that's a rectangular prism. So it's length times width times height. So 15 times 12 times 10. Because that's finding the area of the bottom and then how many slices. And so that's 1,800 centimeters cubed per bucket. So we need to figure out how many times that goes into what we're trying to fill up. I would say let's go with the accurate 15. This guy. So then you're going to take that number, divide it by the 1,800. So 17. Whoops, that's not right. Divided by the 1,800 centimeters cubed. So we took the 117,809.72, and we're going to divide it by our 1,800 centimeters cubed. Then it gives us 65.40. It says 49, so 45. So we would say about 66 pails, or maybe a little over 65. 65 would not fill it. 66 would overfill it. So between 65 and 66 is another answer. And I know it seems really silly, but those things matter. 66 is wrong. 65 is wrong. It's a little more than 65, a little less than 66, or like I said, between 65 and 66 if we're filling it with that 5 centimeter lip. If a tennis ball with a diameter of 3 inches and 10-inch tall cylindrical container where they fit, if I had a tennis ball. Sorry, I didn't read that correctly at all. If I had a tennis ball with a diameter of 3 inches and a 10-inch tall cylindrical container where they fit perfectly, how many tennis balls will fit in the container? So if you've ever seen a container of tennis balls, it's sort of like a cylinder, and then there's a tennis ball in there. In this case, it says this is 10 inches, and our diameter is 3 inches. Remember, again, diameter is all the way across. You could find the volume of your tennis ball, and then the volume of the entire cylindrical container, and then figure out how many tennis balls fit in the cylindrical container. So just like our rectangular pail filling up a pool, we're going to find the volume of a tennis ball, which is a sphere. So that's 4/3 pi r cubed. Our radius is 1.5, not 3. So 4 pi times 1.5 cubed, all divided by 3. So 1.5 raised to the third power. In Desmos, it's a little easier to just put it in as it looks, and the communication between you and your calculator goes a little bit better than working with maybe a TI-84. So I would not necessarily recommend the TI-84 for this guy. So it's 13.5 pi divided by 3. That's 4.5 pi. Just still a pretty nice number for our sphere. And then we need to know the volume of the cylindrical container. So since the radius of the tennis ball is going to be 1.5 and the diameter is 3 and they fit snugly into the container, we're going to use the same radius of 1.5. So we're going to do pi radius squared, because that's our cylindrical base or top if you want to think about the top, and then height, because that's how many slices are going to go in the whole container. So pi times 1.5 squared, and it's 1.5 again because it's half of the 3, and then times 10 because they said that's how tall the container is. So 1.5 squared is 2.25, and then we're going to multiply that by 10. Haven't used our pi button yet. And that gives us 22.5 pi. Now, both of those numbers are not beautifully like whole numbers, but they're not crazy decimals. So I would leave them as such and see how many times 4.5 goes into 22.5. And it'll go in there 5 times. Because the pi divided by pi, they basically cancel each other out. Because we're taking our 22.5 pi, that's the volume of the whole cylinder, divided by 4.5 pi. These go away. It's going to give me 5. So that means 5 tennis balls will fit in this 10-inch long cylindrical container that holds a 3-inch diameter tennis ball. Man, sorry, having some word tangles on my tongue. What would the volume of the space around the tennis balls inside the container be? So if I have 5 of the tennis balls in there, so I'm going to go back to this guy. That's 5 in the tennis ball. So 4.5 times 5. It's going to give us our 22.5. Ooh. Well, the volume of space around the tennis. It's a perfect fit. So I think it'd be 0. But ideally, you would take the tennis ball, take their volume, subtract it from the volume in the cylinder. In this case, it's a perfect fit. So likely, oh, we did this wrong. I did that totally wrong. The reason this doesn't work is because we can't melt tennis balls into this container. If we could melt tennis balls, 5 would fit. If the diameter is 3, 3 is this way as well. So if 3 inches have already happened this way, 1, that would be 6, 7, 8, 9. So that's 3 tennis balls. And then we would have an inch left over at the top. So only 3 tennis balls, like full tennis balls, would fit. Like if these were, let's say, ice, maybe like snowballs, then you could fit 5 because you could pack them in as far as your actual volume. But only 3 are going to fit in this container because you're going to end up with a 1-inch gap at the top, and that's because it's 3, 6, 9, and then there's a 1 because it's a 10-inch container. So it means only 3 full tennis balls will actually fit in there. So 4.5 pi times 3 is how many will fit into the entire cylindrical container. And that's 13.5 pi. That, subtracted from our 22.5, will be the area around the tennis balls. So 22.5 minus 13.5. Again, we're just ignoring the pi because they'll take care of themselves, just like we showed in this math here. But again, that's with melted tennis balls, not actual tennis balls. And then so that would leave us with 9 inches cubed around the outside, after we take our 3 tennis balls worth of volume out of the cylindrical container. Hopefully I didn't make that really, really complicated. After that, so these are a bunch of slant height examples. I will get into these on Thursday. I think will be a better idea instead of rushing through them now. So we will work on these, and then also the density problems that are below it on the packet. And then if we have time, we'll get into lots more and probably actually skip over the basic volumes that are shown here in the diagrams and get down to the word problems and then your rotations, because the rotations at the back of this packet are very similar to the EOC release question that had to do with volume and putting it on the coordinate plane. So again, that's another one of those. I believe the IXL is pretty good at showing like the shape, but you have to be able to visualize it. All right, so until next time, as far as the videos are concerned.